subject I am very passionate about, X-ray diffraction. I would like to introduce myself. My name is Ahmed Abdelmohsen. I have a Bachelor of Science Chemistry, excellent with first class honor. I have a Pre-Master of Material Science and Technology with great excellent. I have the prize of the best presenter and the best graduation research in Faculty of Science. I have a Erasmus Scholarship FAIL program. I am working as a chemist at Central Laboratory in Egypt, responsible for creation of advanced device, atomic absorption spectroscopy, dynamic spectroscopy, graphite and hydrogen generation. In order to be familiar with X-ray diffraction, you should be familiar with some topics in crystallography. So I would like to start with some definitions related to crystallography, such as the type of solids, what is crystals, Faraday lattice. Then I will shift to history of X-ray diffraction, spectra, production of X-ray, how X-ray interact with matter, single crystal X-ray diffraction, powder X-ray diffraction, and finally how to match X-ray RD with diffraction pattern from high resolution camera. Types of solids. There are mainly three types of solids. The first type is single crystals, I mean atoms that are arranged in a regular manner. In polycrystal, the second type, periodicity of the structure get interrupted and there is a dream boundary between them. Plus the type amorphous, the periodicity is completely lost. What is crystal? To understand the concept of crystal, first you should understand what is lattice. Lattice is infinite regular arrangement of points that can be determined mathematically, and by placing the basis, which may be also a group of atoms in the point of lattice, you can found the crystal. So Faraday classified lattice in two main types: two-dimensional Faraday lattice and three-dimension. Two-dimensional are main five types, starting by oblique, rectangular, center rectangular, hexagonal, and final square. The main difference is interatomic distance between them and angles. Second type is a three-dimensional Faraday lattice. There are main 7 systems consisting of 14 types. What is X-ray diffraction? X-ray diffraction is a non-destructive technique used for determination of the crystallinity of material, depending on more than 70,000 references in the International Center for Diffraction data, by relating the resulting peak to this reference. So, history of X-ray diffraction. X-ray was discovered by the German scientist Göttingen in 1895, and it was called X because the unknown nature of this ray in this time. X-ray is a type of electromagnetic radiation with wavelengths in the range of 0.0 nanometer to 100 nanometer and frequency in the range of 30 beta hertz to 30 x hertz. It's located between ultraviolet and gamma ray with nature which is similar to ultraviolet but with shorter wavelengths. The wavelengths of X-ray should be equal to or lower than the interatomic distance of material in order to be able to determine the interatomic distance and angles. So, production of X-ray. Now we can imagine the tube in the apparatus and how X-ray is produced. It consists of two main electrodes, anode from tungsten and cathode from copper or MO molybdenum. As soon as we apply a high voltage between these two electrons migrated from anode to cathode and initiate the production of X-ray from cathode. For instance, if we apply 30,000 volts between these two electrodes, the velocity of these electrons are equal to one-third to light velocity. That can be determined by this equation. In order to illustrate how X-ray interact with matter, first you should be acquainted with Bragg's law. For instance, the X-ray incident is just crystals, and we have two different rays. The path length of the second ray is different from one of the first ray by A, B, C. So we can determine
your anode cathode. You have to change.
Change both.
The cathode is the filament, and the anode is the material where the electrons reduce the X-rays.
So I confused. Okay. I
Simply change it.
Okay, I should change. Okay, thank you. So here we can determine the angle of incidence is equal to the angle of scattering, and the path length difference is equal to an integral number of wavelengths as illustrated here. So we get the final Bragg's law in lambda equal to 2d sine theta. So there are two main factors which affect the different intensity of X-ray. So if you are working in this field, you can see there are different intensity here. Different intensity, one with higher intensity, one with intermediate, and one with low intensity. So what are factors that are affect this intensity? The first factor is atomic number of atoms. When you look to the lattice or for the crystals, you are concerning with something like unit cell, something like the presence of different atoms here. But X-ray is different. X-ray is concerning with the electron density. Some with low electron density, some medium, some with high electron density. So we get the final rule. The heavier an element, the more electron it has, the stronger it scatters X-ray. And you can imagine here, starting from hydrogen passing by boron to nickel and lead, X-ray scattering power increases. Now you can get more details. As soon as we apply X-ray to powder sample, X-ray ionized electrons and oscillate out of the atoms. At the same time, or after this process, electrons from higher energy level drop down into this vacancy. Electrons from L level to K level produce K alpha X-ray characteristic radiations, and electrons from M here to K produce K beta X-ray characteristic X-ray. And we have this nice relation between wavelengths and relative intensity. Second factor is the orientation of the particle in the powder sample. I think I have some experience in preparation in the materials. I prepared this material in Egypt before coming here, but it's very difficult to control the orientation because in this case, it's very difficult and very expensive to control orientation and dimensions of this material. But in the first case here, we have controlled orientations in one side. This is different, so we have here different intensity according to the direction. Now we are going to shift to two types of X-ray diffraction techniques. There are two main types: single crystal X-ray diffraction and powder X-ray diffraction. I'm going to summarize this in just two sentences. The main difference here, or the main advantage of powder X-ray diffractions, is not time consuming. You can do characterization for sample in just 10 or 20 minutes. But single crystal, as I worked in the first semester with Professor Vorkmers in characterization of some porous material, it may take couple of days. So I'm going to introduce only in this preparation of the sample for measurement. In case of single crystal X-ray diffraction, first of all, we should cut and depict one crystal under optical measurement, and we should select this crystal according to special criteria. And the dimensions of this crystal is depending on the size of mounting you choose here for measurement. And if you use some material, and this is usual in all material, you should use some types of oil, because this prevents any reaction between the material and the air, the enhanced adhesions with this mounting, and minimize absorption effect. After choosing of material and preparation of material for measurement, which is a little bit time consuming in comparing with this of X-ray powder diffraction, and I will illustrate it now, you should adjust the position of crystal here, just in the way of X-ray. Then processing of measurement takes place. And you can do analysis for data by using computer software, and you can determine backing and unit cell of the material. X-ray powder diffraction. First of all, you should grind your sample well, and then you put your sample out. Then you should add your sample in the sample holder here, and you should adjust the surface by using a glass sheet. There are different types of sample holder, and that I used in Egypt for preparation of sample for X-ray measurement. I prepared some nanomaterial here in Egypt before coming and did characterization, and we can see some nanomaterial. So I am showing this to illustrate this point here. As soon as you do characterization, you get these peaks from your apparatus here. So now you are searching for matching. This appears first, and then you try to match this is lower here with one here. So you try 1, 2, 3, 4 until to get all of this complete matching here. This high intensity with this one, this with this one, and here. If you can do matching 100%, it's okay. It will be so fine. But now we have 90, 80%. It's very good. And you get here the number of cards I mentioned before. We have more than 70,000 cards in ICCD. And here, scale factor and glutathione. In addition, we have nitric oxide, the same, 90-80%. We have glutathione. We have here the different intensity peaks. This is a card. Okay, you can see in your card, you can see crystallographic parameters. You can see the crystal system itself is very important because you are going to do some measurement now or some calculation depending on the type of crystal system here, the space group numbers, and you can find angles, alpha, beta, gamma, and the interatomic distance in details. Okay, now XRD and high resolution thin diffraction pattern. In order to publish papers, it's very fine, and it's required now for the prestigious journal to do this. And I'm doing this in my paper now. First of all, you should determine the spaces here between pattern by using computer software, by measuring and give this value and divide by 1, 2, 3, 4. As you increase, you will get precise measurements. Then you will select appropriate HKL relating to two spaces here, and then you should calculate the angle according to the crystal system, as I mentioned now, external crystal system, and you get here, for instance, 90 degrees between them. Then finally, you get your final matched pattern. Also, you can use this equation for calculation, but computer software is more easy. I dedicated this work to my faculty in Egypt and to you and to my parents. And thank you.
Thank you very much. So, are there questions? Maybe practical points of view, that's also interesting. Yeah. How a real XRD measurement is then finally worked with these cards and the comparison, and you try to match the peaks, that's how to prepare the samples.
Yes.
Even when you have a little crystal, a very tiny one, or powder diffraction. So are there other questions? Where is the institute located?
Egypt?
Yeah. In which city?
The Swift University is near to Cairo University by 100 kilometers. It's a new university called the Faculty of Postgraduate Research and Advanced Science, new faculty in the Swift University, concerning with advanced science, nanomaterial, biotechnology, environmental. Okay, thank you.
No questions? Okay. We will be together. So.